is not a regular trig, this is an inverse trig, and so therefore you put it on the outside so as not to cause any confusion between the two. Alright, so this is our expression now. So we really need to take the derivative of top. So the derivative of top is what? Tan inverse, I need 1 over 1 plus x squared. Instead of putting x squared, I'm going to put this expression, right? Guys with me on that?
Say that again.
What is the derivative of tan inverse? Well, it's 1 over 1 plus x squared, right? Sitting over there on the middle left. But the inner function is not, it's not just x sitting there, it's x squared plus 4. So wherever I see x here, I need it to read x squared plus 4, right? That's how the chain rule always works. You keep the inner function inside.
So it'd be x squared plus 4 squared.
So this little part here, just take out this out of here.
1 over 1 plus x squared plus 4.
Quantity squared on the for that, right? In place of x squared, right, I have the inner function sitting there. And I have to multiply by the derivative of inner function,
12.
which is
2x.
2x, correct. So derivative of x squared plus 4, which is 2x. So this becomes 2x over 1 plus x squared plus 4 quantity squared. So that's this piece now. 2x, 1 plus x squared plus 4 squared.
Wait.
But it's all alone up there, right? This went to 0. So this part is really down below with this, right? It's this fraction, it's this ratio here sitting on top of this expression. So you can push it down, and this bottom part goes with this bottom part, right? Like we did before, right? When you have a ratio over a denominator, denominators go together. Remember that, Franny Hill?
Yeah, no, I'm just looking at the top corner that you have up there.
Yes.
Oh, times the derivative of that
Of
up
the
there.
inner.
Okay.
The inner was just the x squared plus 4.
Mhm.
This square is due to the tan inverse formula. So it should read negative 2x over this denominator, bracketed, 1 plus x squared plus 4 squared times this thing is left down there. Tan inverse x squared plus 4 squared. Yeah.
Wait, okay, so for up top we did the derivative of 10 minus 1.
So it's tan inverse of x squared plus 4.
So you did, so the inverse is, the derivative of that is 1 over 1 plus x.
1 plus x squared.
1 plus x squared.
Right.
So that x, that's making the x squared plus 4, that's, because you're losing me once you do that times the derivative of x squared plus 4 again.
This is the confusing part?
Yeah.
Okay, so chain rule says I gotta take the derivative of tan inverse, right? Okay. And whenever I do that, I've got to keep the inner function the same.
Okay.
So when I take the derivative of tan inverse, I get 1 over 1 plus x squared, but in place of x, I've got to have inner function. Inner function has to still be there. So x squared plus 4 squared.
But now why are you taking the derivative of x squared plus 4?
To complete the chain rule. I must then take the derivative of inner function.
That's like
But
This is the inner, this is the outer.
Of tan inverse? Isn't that the derivative for the chain rule?
Then you take the derivative of tan inverse and then the times the derivative of what's inside because it's another function.
Yeah, this is inside the tan inverse.
Oh, okay.
So
okay.
derivative of outer gives us this expression, and the inner is still inside,
Okay.
times derivative of inner, and that finishes off chain.
Okay, I see.
Okay. Then I'm just combining this denominator with this one. Since this term is gone, it's just a fraction over denominator, so you can do that. You should do that. Okay, so there's our answer. Good enough?
I think it's getting better. Yeah.
Okay. So one other thing to mention,
Oh. Yeah.
and that is special thing about inverse functions. So if y equals f of x, and you have a particular point on this function, so y naught equals f of x naught, right? X naught